Hello guys, welcome back to ptet.chemistry channel. So in this tutorial video, I'll continue this lecture tutorial series. This is for the O-level or the IGCSE level kind of chemistry, which is suitable for any year 9, which is a 14 to 16 years old curriculum. So it's the beginning of year 9 curriculum where students will have just started to learn about formulas, chemical formulas, how to get their formulas and stuff. And I cover all that in my previous lecture tutorial. So we're going to continue these lecture tutorials on constructing word equations as well as all that symbol equations based on the formulas that we learned in the previous lecture tutorials. And ionic equation will come afterwards when we have finished and kind of master these word and symbol equations. Stat symbols are also going to be covered depending on what informations are given in questions, as well as applying really what you know from your vocabulary, so your chemistry vocabulary based on what you know about structure and bonding, what kind of states do they exist as at room temperature and pressure. Last but not least, we'll also do this deduction of the symbol equation with stat symbols given all the information from the question. So it's basically just reading the question and thinking about their stat symbols, and of course whatever equation you write starting from this level, starting from O-level or IGCSE level, whatever equation you write, you have to balance it. If it is not balanced, most likely it's because you have gotten the wrong formula or you have just forgotten to balance it. So let's just recap a little bit of these kind of things, starting from the names of compounds. So HCl is a molecule. If you remember your structure and bonding, which I did the lecture tutorial a while ago. So you will have chlorine from group 7. Group 7 means 7 outer shell electrons, and we have to show all the outer shell electrons when we do dot and cross. But I get my dot and cross from my display formula, which is nice and easy to count that hydrogen forms single covalent bond, and chlorine being a group 7 element, it will form one single covalent bond because with the 7 outer shell electrons, it wants to complete its outer shell, which is the third shell, so it fills up to 8 electrons and therefore obtain a noble gas configuration. Same for hydrogen. In the first shell, it will share one of its electrons and share another one from the chlorine, and therefore get a fully filled outer shell. So there's the dot and cross for hydrogen chloride. The name is called hydrogen chloride molecule because it's a pure substance. It's just existing as HCl covalently bonded. It's a gas because of its low boiling point, so it has got low boiling point, and it's a result of its simple molecular structure. So we can imagine that simple molecular structure, so we are just breaking the weak intermolecular forces of attraction between the molecules as we boil it. And of course it's a compound and there's a pure substance, there's nothing else that is present together with it, and it will have a fixed melting and boiling point because it's a pure substance. Alright, now HCl aqueous has a different name. You don't call it hydrogen chloride, you call it hydrochloric acid because there's HCl dissolved in water. So it's the HCl dissolved in water, and there's a reaction that results in the breaking of the covalent bond. So this covalent bond will break when you do that, and what it actually get is actually H3O plus Cl minus. Typically, sometimes you can write this as such, H plus Cl minus. So this is talking about full dissociation into H plus ions in water, and this is related to the definition of a acid. So an acid dissociates, or it breaks into H plus ions, or it ionizes, it forms ions in solution in water to give you H plus ions, and that's why it's acidic. HCl is hydrochloric acid, HCl gas is hydrogen chloride. This is a molecule and a compound. These are ions, and these can conduct electricity because they are free ions in solution. Aqueous means dissolved in water, so you have both HCl and you have H2O, so you are an impure substance. In fact, you are a mixture. Okay, and of course a mixture will not have a pure will not have a fixed melting and boiling point, so they will have variable melting and boiling point. So in terms of talking about salts, so salts contain one cation and one anion. I say usually because there are some salts they are called double salts. So you can watch one of my experimental tutorial video where double salts is a mixture. It's a mixture of two or more salts together. So remember that mixture is just two or more substances mixed together. So individually the salts will just have one cation and one anion, but then when you have a mixture of salts, then you could have many more cations and many more anions. Double from the name itself suggests it's actually just two salts. I'm just outlining the fact with more here, but I should probably cancel that out because double salt is essentially just a mixture of two salts, the double giving it away. Yeah. So acids are used to obtain salts. So acids will form salt, and therefore when you are talking about word equation, that's using words. When we are talking about chloride salt, so chloride salt contain this ion called chloride anion, Cl minus anion. It comes from this acid called hydrochloric acid. It will give you chloride salt. If you have acid reacting with something, it will give you a salt. It will give you a salt of the name that correspond to whatever acid you use. Hydrochloric acid give you chloride salt. Sulfuric acid, H2SO4. H2SO4, this is basically how H2SO4 looks like. So the sulfur forms 6 covalent bond, and it allows itself to do that because sulfur is from the third period. This comes from dot and cross structure and bonding. Third period element, you can have more than 8 electrons in the outer shell because you are in the third period. Alright, so sulfate anion would be SO4 2 minus. So you're losing the H plus. Remember, acid dissociate into H plus ions in water. You lose the H plus, you lose the H plus. Now you become minus and minus. This is SO4 2 minus. It's called sulfate with the ATE. Alright. On the other hand, nitric acid HNO3 is going to look like this. So this is nitrogen with 1, 2, 3, and 4 covalent bond. When nitrogen forms 4 covalent bond, it will have a plus charge. When oxygen forms single covalent bond, it will have a minus charge. When I say oxygen forms single covalent bond, I mean here the oxygen has 2 covalent bonds, so this oxygen doesn't have a charge. This oxygen forms single covalent bond, so this oxygen has a minus 1 charge. The nitrogen, on the other hand, 1, 2, 3, 4. If in ammonia, it's usually just 3 covalent bond and it will have no charge. But when nitrogen form 1, 2, 3, 4 covalent bond, it will have a plus charge. Overall, there is no charge because plus 1 and minus 1 cancel out the charges. This is how HNO3 actually looks like, and you can draw the dot and cross of these based on the display formula. And of course, now you have NO3 minus. NO3 minus is going to look like this, but then it loses the H plus, you get a minus there. Plus 1, minus 1, minus 1. So plus 1 minus 2 is going to give you NO3 minus. NO3 minus is what you call nitrate anion. So nitric acid, HNO3 give you NO3 minus nitrate salt. Phosphoric acid will give you phosphate salt. Carboxylic acid actually looks like this. You will learn more of this in organic chemistry. So this is carboxylic acid, CO2H or COOH. It will give away this H plus, and then you will get carboxylate. Carboxylate with the ATE is basically the name of the salt, just like this ATE. But of course, you can have nitrite with the ITE and sulfide with the ITE. These are all covered in the previous lecture tutorial. There was a table of anions and cations that you're supposed to know the names of, that forms part of your vocabulary. Alright? Now, in terms of writing equations, we need to understand a couple of things on what all these numbers mean. So you need to be able to count how many on the left and how many on the right. We count the atoms on the left and on the right. So I'll try and do this slowly so you can understand what is going on. There's a difference between the two in front all right, and the number at the bottom there. So the number in front means, well, let's go through these terminologies, all right? So Na just on its own means there's only one atom of it. 2 in front means two separate atoms, so you have two Na, meaning Na and Na. You got one, you got two separate atoms. This is nitrogen without any number, without any number at the bottom. So there's one atom of nitrogen. These two at the bottom means you have nitrogen triple bond. So this is a molecule. A molecule is made out of two or more atoms bonded together. They are part of your atomic structure definition. So what actually happened then is nitrogen does not exist as an atom at room temperature and pressure. They form bond with itself so that each nitrogen get a fully filled outer shell, and you get N2 molecule, which consists of two atoms. We call this diatomic molecule. Now 3N2, what does 3N2 actually means? It means you have these, and these. You have three of them. So you have got N2, 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 which you can summarize as 3N2. The number in front says that there are three of these. Each of these is the N2 molecule, which consists of the two atoms covalently bonded together. The triple bond here is a result of structure and bonding. Nitrogen is in group 5, so group 5 means it needs 3 more electrons to share from its neighbor in order to get to a fully filled outer shell. We covered all these in the previous topic on structure and bonding already. Now you got H2O without any number in front. It simply means there's just one. So you got one molecule of water which contains two hydrogen. The number at the bottom refers to the atom before it. So the number at the bottom here is not two oxygen but two hydrogen. There's no number next to the oxygen, meaning it's 1, because if it is 0, we don't show it. If we don't show a number, it means there's 1. So one oxygen atom. And this exists as a molecule, which of course you know is just OH2 with 2 lone pairs on the oxygen. Because oxygen is in group 6, it uses 1 and 2 electrons out of the 6 for bonding. You still have 4 more electrons which are not used for bonding. It's called 2 lone pairs of electrons. Now when you have 5 H2O, it means you have 5 separate molecules. So it doesn't make sense for us to write each and every time like this, but I've just shown it out to you that altogether you have 10 hydrogen atoms, because you have 5 of these. So it means 5 of the all of the H2O, 5 of these. So you have 5 times 2, which is 10 hydrogen atoms. So 10 hydrogen atoms. And what you have then is also 5 oxygen atoms. So when you have the number in front, it affects how you count how many hydrogen and how many oxygen, especially when you're trying to balance the equation after this. H2SO4, this is the formula of sulfuric acid. Remember just now we talked about one whole molecule of sulfuric acid, where the hydrogen forms single covalent bond, the oxygen form 2 covalent bonds, can be 2 single, can also be 2 double, and sulfur being in period 3, you have up to third shell, you can have more than 8 electrons in the outer shell because you are from the third period. There are 2 hydrogen atoms, there's 1 sulfur atom, and there's 4 oxygen atoms. So this is just whatever I have just said just now. The number at the bottom basically refers to the atom before it, refers to the element before it, and make sure you count it. The number in front refers to the whole thing, how many multiples of it, such as for the 5 water just now, it means there are 5 of them. So you gotta have 10 hydrogen, 5 times 2, you gotta have 1 times 5, which is 5 oxygen. So when you're writing any equations, do not change any of the small number, because that is part of your formula. This is part of your chemical formula. Once you get the correct chemical formula, you do not change the number at the bottom, because that will mean changing the structure and bonding. We get all of these. Why is it just H2O? Why not H3O? Because of the structure and bonding. The oxygen is nice and happy with 2, 4, 6, and 8 electrons in the outer shell. Each of the hydrogen is nice and happy with 2 electrons in the outer shell after it forms this covalent bond. So formula, the formula unit, one of it is a result of this idea on structure and bonding. And of course, when we balance the equation, we are just changing the number in front. We're just changing the number in front. And when we change the number in front, it can also affect how many numbers of each of the atoms we have. So we must be very careful about counting all of these and understanding the terminologies involved. All right, balancing equations in essence. So what can be advised? My best advice is there's always a key to balancing the equation, so you got to learn this trick as you walk with me through my tutorials. But the idea is you work from left to right. You need to make a informed choice. You need to decide very carefully which one is going to be the one you will balance first, and it will either make your life very easy or it will make your life a lot more difficult. And this thing, if you have a group of atoms such as sulfate, do not count the individual sulfur and oxygen. Instead, count it as if you are counting the sulfate. Okay, of course I can probably remove the charge because we are looking at counting the atoms. Of course, then you must know that sulfate exists as a 2 minus charge for the SO4 unit, alright? But when we count atoms, we don't care about the charges first. We just count SO4. Look how many SO4 on the left and how many SO4 unit on the right. That's basically what it's saying. It saves you time if you treat the whole unit as such. Remember that things like sodium sulfate, Na plus, SO4 2 minus. So you have 2 of the Na and 1 of the SO4. But you could also have things like aluminium sulfate, so Al2 SO4 3. So this means 3 times of the SO4 2 minus. I hope you remember how we gotten that. Al3 plus, because it's from the group 3 metal. And then when it is plus 3 and minus 2, we cross multiply the value. We never ever cross multiply the ions because the ion remain as such. This refers to the charges of the ion that remain there. What we cross multiply is the value. How many is the value? Is 3 there, so it goes there. It's just 3. It's not plus 3, it's not minus 3, it's just 3. The value of minus 2 is just 2. So what this means is Al3 plus. What this means is there are 3 of the SO4 2 minus, and therefore our formula units is going to be 2 of the Al3 plus and 3 of the SO4 2 minus. That's why the formula aluminum sulfate is Al2 SO4 3 times. Okay, the charges will need to be balanced out. Plus 3 and plus 3 give you plus 6. Minus 2 minus 2 minus 2 is minus 6. The whole compound, even though it's an ionic compound, is uncharged because it's a compound, it's not an ion, but it consists of positively charged ion called cations and negatively charged ions called anions. All right, whatever you do when you balance equation, you always have to check. Okay, this is complacency, and a lot of students will make this mistake. If you don't check your work, you will make a mistake. All right, you got to start from the very beginning already. Check and check and check. Whatever equation that's not balanced, it will kill you later on. It will affect all your calculations later on. So make sure you make it a habit to check after you balance an equation. There are 5 equations here. I'll just run up this tutorial lesson, these lecture tutorials, just by quickly going through these word equation. These 5 equations are very powerful, even though they are word equations, because a lot of generalization can be made by knowing these 5 equations. When you're a metal, reactive metal, I must say, it's not every metal that will react with water. Later on, when we do chemistry on metals, you will see that it's only the reactive metals that will obviously react. The non-reactive metals don't show much reaction at all. Metal plus water will give you metal hydroxide. Metal hydroxide is alkaline. So I'm talking about property, not name. Alkaline is an objective. Not objective, it's an adjective. Alkaline is also known as basic. That means the pH is below 7. It's, hang on. The pH is above 7. All right, I better write that properly. The pH is above 7. That makes it alkaline or basic. Any sort of hydroxide, as you know, hydroxide ion is OH minus ions. If it contains OH minus, is hydroxide, is alkaline or basic. Together, you combine it with any metal cations. Any metal hydroxides are going to be basic. Hydrogen gas exists as H2 at room temperature and pressure. As a result of structure and bonding, you don't get H gas at all, you get H2 gas. When you have acid reacting with reactive metals, reactive metal react with acid. Acid will give you salt, as we talked about earlier. Chloride give you chloride salt, come from hydrochloric acid. Nitrate salt come from nitric acid, sulfuric acid will give you sulfate salt, and so on and so forth. And you also get hydrogen gas. Metal carbonate, remember you will have CO3 2 minus, and then the metal could have whatever metal charge cations you have, but it will be combined with CO3 2 minus. This is a giant ionic structure. Acid reacts with carbonate is a very, very powerful reaction. You will learn this in practical chemistry as part of your paper 3, or whatever they call it in IGCSE chemistry as part of practical science. Practical chemistry, acid reacts with carbonate will give you carbon dioxide. Carbon dioxide gas is produced when you have acid reacting with carbonate. You also get water. There's H2O. You do not get hydrogen gas because, well, it's not a metal plus acid, it's a metal carbonate plus acid. All right. This metal salt also formed as a result of acid reacting with the metal carbonate. Reaction 4 is something that you would have heard of as neutralization. pH above 7, that is base or alkali. Acid have pH below 7, so there's acidic. pH is a value, is a range of value that basically tells you whether you are in acidic environment or alkaline environment. And then we get a neutral solution of the salt in water. That's why this reaction is called neutralization. Neutral pH is pH 7, so we want to get it up to pH 7 where it's neutral, because when you take these two together, they'll give you a neutralization reaction. Acid, anything that contain H plus. Base or alkali, anything that contain OH minus, they will give you the salt and the water. The salt, of course, as we talked earlier, cations and anions. Last but not least, when you have ammonium salt, ammonium ion, ammonium is an ion, do not confuse this with ammonia molecule. Ammonia is a molecule with no charge. Ammonium is an ion with a +1 charge. You should be very, very familiar with these by now. Ammonia gas is NH3 gas. Water is H2O liquid. Alright, and this metal salt comes from the result of NH4 plus reacting with OH minus, and this will give you the NH3 and H2O. The salt comes from this bit here, the anion. So there is an anion there. If I say there's the anion there, the base of the alkali is a metal cation. So it's a metal cation because you have metal hydroxide. Any alkali is a metal hydroxide. And there's the metal cation and the anion from the ammonium salt. Metal cation and the anions together, this green bit will give you the metal salt in your equation. So it will make more sense when we come to examples, and I'll continue that in the next part of the lecture tutorials. Okay, so thank you for watching, and don't forget to click the button on the bottom right to subscribe to ptet.chemistry channel, and share the channel widely with all your friends, your chat or study groups, your juniors and your seniors from school, your relative, your teachers, and whoever else you think the channel might be useful for. This is a series of lecture tutorials. It's pretty much like a lesson itself, and they are different from the usual past paper or question tutorials that I have on the rest of the channel. Alright, so follow me at ptet.chemistry, that's ptet.chemistry on Instagram, Facebook and Twitter to get connected and to ask questions, and yeah, let me know how the learning goes. Alright, I'll see you in the next lecture tutorial.